Sorry, sorry. Up to now it was unmute. So namaste. So we were in discussion with the uh, fourth chapter, that is classification of buildings. So we have seen already different component parts of a building and its functions, and we have seen the classification of buildings as per NBC. Also, we have seen different site investigations of a foundation as per NBC, like trial pits and auger borings. We have seen. So last class we have entered into the foundations. So we have seen shallow foundations also. But now I will again repeat the foundations part. Like I would like to complete shallow foundation and deep foundation here, and also I'll try to complete an bearing capacity of soils also. Right. This is our today's uh, target. So let us see what we have seen yesterday. So the foundations, there are two types of foundations are there: shallow foundations and deep foundations. Shallow foundation is said to be shallow when the depth of foundation is equal or less than the width. So it is called a shallow foundation. Uh, Shallow foundation can be again further classified into spread foundation, grillage foundation, raft foundation, like this. And spread foundation is a foundation. Spread is given to the foundation so that load on the structure is distributed on a sufficient area of the soil. The angle of spread is depends upon the type of material. This is a spread foundation like wall footing, RCC isolated column footing, like combined footing. These are called spread foundations, right? Wall footing is there are two types of wall footing, one simple and another is stepped wall footing. So isolated footings means used to support the individual columns. Simple stepped or isolated or trapezoidal isolated footings are common. So these are some trapezoidal isolated footing. Slope, this is a slope. Combined footing is when two footings are combined together, right? Common footing is provided for two or more columns. That is called combined footing. This may be rectangular or trapezoidal in shape. To achieve the uniform pressure under the footing, uh, combined footing is taken care, right? See, this is a combined footing. Combined footing is provided under the circumstances when the columns are very near to each other, when the bearing capacity of the soil is less, when end column is located near the property line. So combined footing is important. The raft foundation is when the distance between the columns is very less and columns are spread all over the site. Then we'll go for raft foundation. That is nothing but a slab. So inverted slab, you can say. So slab, generally if you see the roof, under the roof there will be a beam. But here in raft foundation slab, upon the slab there is a beam. That is a plinth beam, right? So inverted slab you can see, right? Mat foundation or raft foundation, it will take raft slab is kept projected outwards, distance about 300 to 500 all around the section. So it will be projected from the outward the line, so to encourage the structure in the foundation soil also. Right, see, this is the outward for projections of the foundation, right? So these are suitability for when structural loads are heavy, when the bearing capacity of the soil is low, and when the use of spread footing would cover more than half of the building area, then we'll go to mat footing, right? So then we are entered into deep foundations. Let us see one small video about different types of foundations. Is it opening? So let it will be open in back end. So deep foundations. When the foundation has to carry heavy structural loads, so deep foundation is recommended. So deep foundations are recommended in soft soils when the bearing capacity of the soil is very low. So we will go for deep foundations. So deep foundations are pile foundations, well foundations, grillage foundations. Uh, Under reamed piles. These are called deep foundation. Generally, pile foundation and well foundation is called as deep foundations. So there are so many types of pile foundations also there, like friction pile, under reamed pile, right? Let us see this video. What is Yeah, this was the nice video regarding different types of foundations. He has nicely explained from the types of foundation to even types of how to do concreting also. So he has explained deep foundation also. When the foundation has to carry heavy structural loads, and if the bearing capacity of the soil is low at shallow depths, the foundations are to be taken to deeper depths until a hard stratum is reached. Such foundations are called deep foundations. Deep foundations generally carried out in seashore, and if any structure is constructed near the dam site where the water table, groundwater table is high, at a just 1 feet, 2 feet level, at that places, deep foundations are required. There are types of deep foundations. So deep foundations are two types: pile foundations and well foundations, also called caissons. Right. So pile foundations. A pile may be defined as a long vertical load transferring element composed of timber, steel, concrete, or combination of them. The main function of a pile is to carry the load of the structure to deeper depth at which good bearing capacity is available. Means the group of, if you say group of drilling elements which can uh, hold by sorry hold by a pile cap, then construction is done. So situations which demands pile foundations is the live load and dead load coming on the structure considerably large. The construction of grillage or raft foundation is not economical. The seasonal variation of groundwater table is considerable. When the loads from structure are to be transferred to hard strata at a deeper depth through poor or compressible soil strata, when the sandy soils are to be compacted to increase the bearing capacity by means of compaction piles. When the loads are to be taken to depth in a weak soil by virtue of skin friction developed along the length of file. So when the structures are to be protected against uplift pressure or overturning movement. So in case when large inclined forces are to be resisted, so then in these conditions pile foundations are suitable. Piles can be explained as follows depending on their functions. Uh, piles are bearing piles, friction piles, sheet piles, fender piles, anchor piles, batter piles, and compaction piles. So bearing piles means the pile is standing on the end at the depth. It is standing on the hard strata. So that is called bearing piles. So showing a pile foundation here. See, this is concrete pile. This is how concrete pile is made. This video is showing how the concrete piles are constructed at site. This piling for a foundation, we can say that teamwork, like all piles together joined with a pile cap, and their foundation of the building can be constructed. So the loads are distributed by all piles to the soil. This is showing pile driving methodology to the site, right? So let us see one by one. So bearing piles, these piles are which are, yeah, these piles are driven through the soft or very soft or overlay soil, and another and their bottom is made to rest on the hard rocky strata or bed. The end bearing piles act as a vertical columns or piers, right? They form a medium to transmit the load of the structure to hard underlying stratum, right? Friction piles. When underlying soft soil is extending for large depths and it is not economical to construct end-bearing piles. So, rather than possible to rest the bottom end of the piles and the hard stratum is not possible. So, the load is borne by the piles through friction developed between the surrounding soil of the piles. See, like this, these are the this is end bearing piles, means the piles is resting on the hard strata and pile cap is provided and the construction is started. So here piles are not rested on hard strata, but the piles are uh, constructed in a better manner and close to each other, and the gap between the piles is filled by the sand, so the skin friction will be developed. Based on the skin friction, the piles are working and resisting the structure. So these type of piles are called as friction piles, right? Classification of piles according to the material. So steel pipes, cement concrete piles, timber piles, composite piles, sand piles, different piles are there. So we have seen the cement concrete piles in the video, pile driving video, right? Cement concrete piles are piles may be mainly classified into two. Board cast in situ piles are precast piles, driven piles. In that video, we are seeing precast piles. So cast in situ piles means the piles are casted at the site only. So precast sites piles are casted piles are casted at anywhere in a casting yard and driven into the site, right? Cast in situ. There are cast with cement concrete at the site location immediately after the borehole is drilled and reinforcement cage is placed in position, right? So advantages of cast in situ piles are there is a less wastage of material as the piles are constructed in a site only, as the pile is desired length is only constructed. The stresses of handling and driving, transportation are completely eliminated, and hence no extra reinforcement is provided. The time spent on curing is saved. Means the precasted piles, it should be cured in casting yard, and other after the fixing also you have to cure, so that curing time is saved here. The piles are more sound, there is no danger on its breaking, and they are not subjected to hammer blows or driven. So precast piles are driven with the hand blows, hammer blows, so here it is not there, right? These are some advantages of cast in situ piles. Transportation cost of piles is saved. Lightweight casing shells are used, which are easier to handle and to drive into the ground. They can take up heavier loads by improving their cross-sectional profile. Example, by providing pedestal or under rimmed, etc. Disadvantage is it is very difficult to maintain proper compaction during the construction, and it is not possible to maintain the reinforcement in correct position or correct vertical alignment during the construction operations. Means vibration, everything will be done. So the dry soil absorbs water from fresh concrete and does not develop full strength. These are the some disadvantages in cast in situ piles. The unreinforced pile may be break with a small amount of movement of soil in lateral direction. All right. So next, precast concrete piles. These are cast at economical place, cured and brought to the site. And then they are driven into the ground by hammer blows by conventional method. So advantages are the reinforcement is maintained in the correct position. The best quality of concrete can be produced for the casting piles with a little care. So proper curing is done, hence the concrete attains its full strength before it's used. The driving of such piles is easier in soft soils and wet soils. The driving of adjacent piles does not produce any additional stresses in the pile. So the piles can be driven underwater also. The number of piles can be cast in advance at a convenient place, and rapid driving progress can be ensured at the site. Defects of casting may be examined and repaired before driving the pile. The precast piles are having higher resistance to biological and chemical actions of the ground, because it was well cured before transporting them to the site, right? So disadvantages are these piles are very heavy and difficult to transport. The shocks and vibrations make them weaker. The weak joint is formed due to overlapping to form additional length. So on the other hand, the material is wasted if long pile is to be cut to a size. Like if you want to see a drive a 30-meter pile, you cannot cast 30-meter pile at a time. So 10-meter piles or 3-meter piles are casted, and each pile is driven one upon the other. So well overlapping like that. So there is a material waste, and the overlapping joint may be become uh, weak, right? So and extra reinforcement is essential to take care of handling and driving truss stresses. Progress of work at a site may be delayed due to inadequate supply of piles in a short notice. If proper care is not taken, the piles may be damaged during the transportation and driving or casting there. So under rimmed piles next. Under rimmed pile foundations are cast in situ concrete piles having one or more bulbs are called under rimmed. Under rims form by enlarging the borehole of the pile stem. Single under rimmed piles has only one bulb at the bottom. So when the number of bulbs at the base is two or more, it is called as multi under rimmed piles, suitable for black cotton soils and other expansive soils. Right. So just see one. This is the under rimmed piles. This animation is showing the how the piles are carried out. See, these are all piles. These are pile caps. It's a grillage. Yeah, these are under rimmed files which have shown. See, this is under rimmed files means this is a bulb at the end. If it is a one bulb, it is a single under rimmed file. If the bulbs are more than two, it is called a multi under rimmed files. This is a bulb which is provided at the bottom to make additional grip for the piles. Right, first bulb and second bulb like this. Right. And pile caps. Piles are not usually used single, but are formed into a group. So, group of driven piles. The load is distributed over the heads of the piles in the group by means of a reinforced cast in situ concrete pile cap. Right. So, next well foundation. Well foundation is a watertight structure made of wood, steel. This is a well foundation audio, sorry, animation. It is showing. See how the charges are applying on the top of the pile, and the pile is going to driven into the soil. This is how well foundation is working. Yeah, this is what well foundation. Yeah, this is what well foundation is showing. So, well foundation is a watertight structure made of wood, steel, and reinforcement concrete construction for foundations of bridges, piers, abutments, and rivers, etc. And dock structure, shore protection, breakwaters also there. So here it is another video which is showing the well foundation. We'll see later if time permits. And types of well foundations, uh, types of shapes of well foundations are circular, twin circular, double D, twin hexagonal, twin octagonal, and rectangular. These are the different types. And factors affecting the shape of the well foundation is size of the pier, base of the pier, and cost of sinking, easy in construction, tilt and shift during the sinking, and force consideration. Right. This is a well foundation. Uh, Picture. So this is called as bottom plug. This is a cutting edge. So this is a vertical reinforcement what is shown. So horizontal reinforcement, vertical. This is called the body of the well is called staining, and this is the top plug, and this is a well cap, and this is a pier and pier cap. This is a girder, and this is a bearing handle. This is a cross section double D shaped, right? And this is filled by sand. So this is typical diagram of well foundation. Component parts of a well foundation is cutting edge curve, staining bottom plug, bottom top plug like this. Cutting edge means the sharp-edged steel reinforcement angle is provided at the bottom of the well staining to cut the soil below the foundation during the sinking process. Right. This is called cutting edge. Curve means it is mandatory to. It is made of reinforcement concrete and act as an extension of cutting edge during sinking and also gives support to the well staining and bottom plug also. See, this is called curve. This is a cutting edge, the extra portion which is extended from the edge. So this is called curve, right? Staining means it is the main body of the wall uh, made by brick masonry or reinforced concrete. It is act as a coffer dam during the sinking, means not allowing water into the well foundation, right? Like it is impermeable during sinking, and a structural member to transfer the load. Bottom plug, it is made up of concrete, and its main use is to transfer the load from the standing to the soil below, right? Sand filling, a sand filling is provided between the top plug and bottom plug to transfer some portion of load directly on the well. Top plug is made up of concrete, and component parts of a well foundation, well cap. The shape of the well cap is similar to the shape of the well with 150 mm projection around, and to transfer the loads and movements from the pier to the substructure. And the next, bearing capacity. The supporting power of a soil or rock is referred to as a bearing capacity. So this is the main value which we can, based on this bearing capacity value only, we will go for structure. So based on the loads what we have calculated as per the structure occupancy. So we'll compare with the bearing capacity of the soil. If it is a permissible limit, then we will go to construction, right? So ultimate bearing capacity is defined as the maximum load per unit area which a soil can withstand without any yielding or displacement. This is called ultimate bearing capacity. And bearing capacity of the soil depends on moisture content, cohesion, size of particles, compactness, rock and sandy soils. The ultimate bearing capacity means it is defined as the minimum gross intensity of pressure at which the soil particles are at the verge of shear failure, right? So safe bearing capacity is defined as the maximum bearing capacity, maximum net intensity of pressure which can the soil particles can carry without excessive shear displacement. So ultimate bearing capacity, safe bearing capacity, and factor of safety, right? So safe bearing capacity while designing the structures, the soils are never loaded up to their maximum bearing capacity. The value of permissible loads taken for the purpose of design is known as safe bearing capacity or net bearing capacity. The value of safe bearing capacity is only a fraction of ultimate bearing capacity of the soil. So the formula is like this: safe bearing capacity is equal to ultimate bearing capacity by factor of safety. The value of factor of safety is 2 to 3 for ordinary buildings, and 2 is taken, whereas 2.5 to 3 for heavy structures it is taken, right? Safe bearing capacity of rock, like different values: soft rock, cohesive soils. There are some values. This is what we have studied. These are the some questions which can be triggered from this chapter. So this is the end of the class. So thank you.